All right, so these are sort of how does negation distribute over and or, but we need another thing as well, which is how do you distribute and or over each other? So what is by themselves and or each satisfy associative and commutative properties. So P and Q has the same truth table as Q and P. And P and Q and R is the same thing whether you group it this way or not at all. It's going to have the same value, and it's the same thing as P and R and Q and so forth. Similarly, P or Q has the same truth table as Q or P, and P or Q or R is going to be true no matter how you group. Is going to have the same truth value no matter how you group the terms. Okay, so these are sort of associative and commutative. But what about here? We need to evaluate something a little bit more complicated. We have combination of and or. How do you combine P and Q or R? This is just like A intersect B union C. It is just like that. Okay? So it's either P and Q. This is true if either Q or R is true, but P has to be true no matter what. Right? So this is P and Q or P and R. Right? Okay. What about P or Q and R? Okay, this is just like A union B intersect C. Right? And is like intersection, or is like union. Yep. So this is P or Q. And helps that I write what I'm saying, P or R. Right? Just as a sanity check, no matter what. Okay, so if P is true, this is true, right? No matter what Q and R, whether Q and R are true or not. Is the same true on this side? Yeah, because if P is true, P or something is going to be true. P or something is going to be true. We'll have true and true, which is true. Right, just sanity check, yes? Okay. All right, how do we use this stuff now? We have all the rules we need to try to simplify this further. Yes?
Just a quick question. What if Q is magic plus and Q and R are both false? Is P is Q?
If Q and R are both false, P or Q, but P is true, then P or Q is true or false, which is true. And this is also going to be true or false, which is true. So, yeah. Okay. All right. So now we've got this funny combination of ors and negations and blah, blah, blah. Can we somehow simplify this using these sort of algebraic rules for combining stuff? Well, let's try something, right? What can we do? We could call this one object, and that's that and something or something. Yes? And so this and something or something is like this and something or something. We could apply this rule for the sake of argument to see where it gets us. Yes? So what happens if we apply that? We get that and something or something is this and this or this and that, right? So what does that look like? Kind of running out of board space. Maybe. The question is it simplifying it? We'll see where we get. Okay. So using this rule, this becomes not P or Q and not Q, or not P or Q and P. Yes? Did I? So far, so good? Okay. Look at this. This is not P or Q and not Q. How can this possibly be true? Yeah. The only way for this to be true is if not P is true and not Q is true. Right? So the Q here isn't helping. It's not changing anything, because the only way for this part of the and to be true is if Q is false. If Q is false, then this is something or false, and that doesn't help. Does that make sense? Yep. So this piece is really the same as not P and not Q. Does that? Okay, suppose Q is true. Then this is false, and as a result, this whole expression is false. Right? Because this is something and false. Suppose Q is false. Well, then this is true, and the whole thing becomes true if not P is true. So this whole thing is true if both P and Q are false. It can't be true if Q is true. Okay? So we have this, or what happens here? Well, it's exactly the same thing. In this case, how can this possibly be true? Well, if P is false, then we've got something and false, and this is going to be false. Right? So the only way that this side can be true is if P is true. So then, if P is true, the only way this piece can be true is if Q is true, because P isn't helping. So this side is P and Q. Same thing. P and Q or Q and P is the same thing. Yep. Right. The stuff. Okay. So this was the first expression that we wrote down. Right. That's this. Right. I mean, again, or we can flip things around. So. Okay, so starting with it represented this way, we've now shown by algebra that it's logically equivalent to this, which is where we started.
I know we started with the bottom.
Well, we started with this truth table, and then we came up with this as a way of expressing the truth table, and then said this is actually a shorthand for that. That the way the if and only if is defined is it's defined to be this. Then I asserted that if and only if was equivalent to saying P implies Q and Q implies P. And what this was just simply showing, yes, indeed, that's right. We showed that it's right two ways. One way we showed that it was right was by plugging in values of Q and P and showing that we get this truth table back. And here what we did was did some algebra to show that, in fact, we get the formula back. Okay, two ways of showing the same thing.